Hello everyone. So we will start today. So I see familiar faces, so won't be introducing you. So let's start the session. So we are in week 10 now. So we will be solving week 10 assignment 10, previous year's week 10 assignment 10. So let's start. Okay. I believe today's less only three people have joined because is it because Navmi is there? Ram Navmi is there. Is it because of that? Chalo, you guys won't be knowing if that's the case. Anyways, let's start. So, for week 10, assignment 10, question number 1, a 75 ohm transmission line, okay, a 75 ohm transmission line of length 60 meter is terminated by a 100 ohm load, okay. So 75 ohm transmission line of length 60 meter is terminated by a 100 ohm loads. Okay, a rectangular pulse of width 5 microsecond and magnitude 5 volts is sent out by the generator connected to the line. Okay, take ZG is equals to 50 ohms and mu speed of the wave is equals to 0.1 c. Using the information to solve questions 1 to 3. Okay. So here a circuit is given. Yeah. See, oh, all right. Sorry. I do that every time. Can you see now?
Okay, ma'am. Okay, ma'am.
So a 75 ohm transmission line. Uh, so a circuit is given. Okay, and it has a 75 ohm transmission line of length 60 meters. Okay, and the load has a 100 ohms. Okay, and it is said that at the generator side a rectangular pulse of width 5 microsecond is sent with magnitude of 5 volts. All right, so a rectangular pulse. So if we say it's a 0, something like this, 0 5, this is time. All right, time in microseconds. So it's saying that a rectangular pulse of this is 5 volts. Okay, a rectangular pulse of 5 volts is sent out by the generator connected to the line. Take Zg is equals to 50 ohms and the speed of wave is equals to 0.1 c. C here is speed of light. Okay, so you understood the question. Now it's asking total current for t in between 4 to 5 microseconds. So did you understand the question? So okay, I will repeat the question again once. So here what is saying is a circuit is given with a transmission line, all right, and some parameters of the transmission line is given, and it is said that a rectangular pulse is given to this circuit, okay, with 5 microsecond time and 5 volts amplitude. All right, now it's asking total current at the generator end. Okay, so I have already discussed with you in the previous assignment how we calculate the reflection of the current, much current after every cycle, how much it becomes, right? I have discussed with you in the previous assignment. So let's try to solve this question in that similar way. Okay, so first we have to find out the steady state current. So first the initial current will be, this is the formula, right? One second, I will erase this. So initial current, first we will try to calculate the initial current. Okay, so for initial current we know Zg and Z0 right? Huh. So yeah, we know Zg 50 ohms, Z0, right? And Vg we know. Where is Vg? 5 volts. Yeah. So Vg we know, right? So initial current will be Vg upon Zg by Z0, which will be equals to 5 upon 50 plus 75, which will be equals to 40 milliamperes, right? Is there any problem here? Will you be able to find out initial current?
Okay, ma'am.
Yeah. Okay. So the first thing uh, you need to find out is the initial current. Okay. Now let's find out the transit time. So what will be the transit time? The transit time will be the length of the transmission line divided by the speed of the wave. Okay. So the length of the transmission line divided by the speed of the wave, which will be equals to 60 upon speed of the wave, which is equals to 0.1 into 3 into 10 to the power 8. So from here we got transit time equals to 2 microseconds. So let's say the current goes like this, right? So here after the transit time will be microseconds, right? Right, so, something like this would be happening. It would be reflecting from, right, via the transmission line. So the current again will come here at 4 microseconds, isn't it? At generator end the current will come back at 4 microseconds, right, to get reflected. So अंडरस्टूड राइट? यहाँ तक समझ में आ रहा है ना सबको क्या हो रहा है? Okay, no problem. Let's go ahead. Now let's find out the current reflection coefficient. So there will be two reflection coefficient, isn't it? One will be gamma g, uh, one will be gamma g, another will be gamma l, right? So we will find out gamma g and gamma l minus gamma g and gamma l, which will be equals to z. This is the formula. Discuss this in the previous assignment as well, right? So I hope you guys understand that. तो गामा एल एंड गामा जी हम यहाँ से निकाल लेंगे using the formula. Now what you need to notice is there will be overlapping, right? Because the time taken by initial voltage to go forth and back is 2t1, right? That is 4 microseconds. So which is less than the pulse duration. So pulse duration here is for 5 microseconds, isn't it? The pulse duration is for 5 microseconds, but there will be overlap, right? Because this is 5 microseconds, the voltage at generator end, and the potential voltage is 2t1, the 4 microseconds. So which is less than the pulse duration. So at the generator end, what will happen is from 0 to 5 microseconds, the incident current will be equals to reflected current, right? Microseconds, there will be a reflection, right? So from 4 microseconds to 9 microseconds, the incident current will become the current into the reflection coefficient of the generator, right? Of the load. This current multiplied by the gamma g, right? So this will be minus 1.143 milliamperes. So for time t equals to from 4 to 5 microseconds, what will be our total current? Our total current will be 40 minus 5.714 minus 1.143, right? Which will be equals to 33.13 143 milliamperes, which is this one. Got it? Is there any problem here? समझ में आ
नो
रहा
मैम.
है? ओके, ठीक है, ठीक है. So let's go ahead. तो ये वाला अगर क्वेश्चन समझ में आया तो लेट्स ट्राई टू सॉल्व द सेकेंड क्वेश्चन देन. So in the second question it is asked at the load end. Notice where it's asked at load end. The total voltage for time t in between 3 to 6 microseconds. Okay. So again what we have to do is we know the voltage reflection coefficient, which is gamma g and gamma l we know, right? Now the initial voltage, first we have to find out the initial voltage, similar to the first question where we found out the initial current. Initial current पहले क्वेश्चन में फाइंड किया था. सिमिलरली हम सेकेंड क्वेश्चन में भी इनिशियल वोल्टेज फाइंड आउट करेंगे पहले. तो इनिशियल वोल्टेज के लिए सिंपल किरचॉफ्स लॉ, वी नो किरचॉफ्स लॉ, सिंपल स्टेडी स्टेट कंडीशन है. तो वी विल पुट दैट एंड वी गॉट Z0 Vg upon Zg plus Z0, which is equals to 3 volts. Understood? Now, अब again at load end. So first goes like this, right? So till here, before time t equals to 2 microseconds, the voltage will be here. Voltage will be equals to 0, right? So this. Now since the pulse is for 5 microseconds, right? So from time t uh, equals to 2 to 7 microseconds, our initial voltage will be 3 and the reflected voltage will be equals to the gamma load into 3, right? That is 0.429. So from here after 2 microseconds, so that is from 3 microseconds to 6 microseconds, the total voltage will be the 3 coming 3 plus reflection coefficient of the this thing uh, of the load into 3, right? So 3 to 6. So it will be equals to how much? It will be equals to 3.429 volts, right? So this will be the answer. Is there any issue here? समझ में आया क्या हुआ है?
नो मैम.
हाँ.
नो मैम. नो.
हाँ, तो मैं एक बार फिर से समझा देती हूँ. क्या हुआ है यहाँ पे कि दो माइक्रो सेकेंड्स तक तो हमारा लोड पे वो था, बट आफ्टर 2 माइक्रो सेकेंड्स जो वेव होगा वो ट्रेवल कर लिया होगा, राइट? क्योंकि ट्रांजिट टाइम हमारा 2 माइक्रो सेकेंड्स है, राइट? तो हमारा वोल्टेज वेव ट्रेवल कर लिया होगा फ्रॉम द इलेक्ट्रोमैग्नेटिक वेव ट्रेवल कर लिया होगा फ्रॉम जनरेटर एंड टू द लोड एंड. तो वहां से फिर वो उसका कुछ रिफ्लेक्शन होगा एंड ही प्लस द रिफ्लेक्ट जो भी रिफ्लेक्ट हुआ है, तो जो हमारा रिफ्लेक्ट हुआ है वो 0.429 है और जो हमारा इनिशियल वोल्टेज है वो 3 है. सो टोटल वोल्टेज एट द लोड एंड विल बी 3.429 वोल्ट्स. ठीक है, चलो लेट्स गो टू द थर्ड क्वेश्चन. Now the third question here is at the load end the total current for in between 7 to 10 microsecond is okay. So now the total current for at the load end is asked. First question was at the generator end, right? First question was at the generator end. Now the second question is at the load end. So can someone from you tell me how to solve this one? Try करो. सोचो कैसे होगा. There will be some reflections, right? Transit time के बाद है ये चीज, so there will be some reflections. So let's go and see how to solve this question. Okay, so at the load end from 60 to 11 microsecond, that is 5 microsecond. Why this 5? Why we are taking 5 microsecond? Can someone tell me that? This 5 microsecond we have taken because of the our pulse voltage that we send, right? The pulse voltage has a time of 5 microseconds, so that's why the load end it will have a 5 microsecond. But when we are counting for the reflections, we will count it for 4 microseconds. That is the transit time we will be counting for 2 ti, that is 2 into transit time. Okay, so at the load end vi will be again the reflected one into the gamma g minus gamma g, which will be equals to this. And similarly this value came here, again reflected, so it will be gamma L into the reflected wave, which will be equals to this. So at the load end, the total voltage will be for 7 to 10 microseconds will be this minus this, that is equals to this. So now the total current will be um, yeah, the total current will be this current divided by the impedance, right, which is equals to impedance of the load impedance, so which is equals to 0.98 volts. So this is okay, once again I'm talking here, I'm talking about the voltage, right? We have calculated the voltage, we will be calculating the voltage, and then we will divide it with the impedance and we will get the total current. So the total current will be the load total voltage at the load end divided by the impedance of the load, that is 100 ohms. So we will get minus 0.98 milliamperes. ठीक है, समझ में आया? एनी इशू, कोई प्रॉब्लम है क्या इस क्वेश्चन में? शुड आई गो अहेड?
No, ma'am.
ठीक है, ठीक है. तो all these three questions are very similar to one another. ठीक है, if you solve one question, it will be easier for you to solve all the other two questions as well. It is based on the same concept. Okay, so now let's go ahead and solve question number 4. So which one is the correct regarding the propagating waves in positive z direction in uniform waveguide? Okay, so propagating waves are asked have to be considered in the positive z direction in a uniform waveguide. Okay, so three things you need to know. It's asking about the propagating waves, another thing is regarding positive z direction, and in which medium it is asked for uniform waveguide. Okay, so think about it. Okay,
Hello, madam.
go ahead.
First one, madam. Why? Because, for example, electric field is varying with x. Magnetic field is y direction, means direction of propagation. There is no electric and magnetic field. Direction of propagation it contains only for electromagnetic waves. So first one, madam.
First one. Okay, so transverse magnetic wave contain a non-zero Ez, but at Hz is equals to 0. Okay, so this one, yes, this one is correct. For transverse magnetic waves, the magnetic waves, that is Hz, for positive z direction will be 0 and it will have a non-zero Ez. Okay, correct. Read the second statement. What is the second statement here? The second statement here says uh, transverse electric wave contains non-zero Ez, but Hz is equals to 0. Okay, this one is wrong. One second. Wait. Right? Now let's read the third option. Third option here is transverse magnetic waves contain a non-zero Hz, but Ez is equals to 0. So this one is negating the first statement, right? And we know that the first statement is correct. So this one is also wrong. Now option B and C both. Okay. So this is also wrong, right? Only option A is the correct one. So the correct option here is option A. Okay. कोई problem है इसमें? If here instead of saying this statement, transverse electric waves contain a non-zero Ez, but Hz is equals to 0, instead of saying that, if it have said that transverse electric waves contain a non-zero Hz, all right, not equals to 0, and E of the positive direction is equals to 0, will this statement become correct? About transverse electric wave, if this is the statement, will the statement become correct? Someone?
Hello, yes, ma'am.
Yes. Good, good. Yes, it will become correct. So if this was the option, then you would have to correct this as well as this. But okay, that's not given in the option, so you don't need to worry about it. Okay, let's go to question number 5. The question number 5 here says the cutoff frequency is. So the cutoff frequency is the operating frequency below which attenuation occurs and above which propagation takes place. Okay. Second option here is the operating frequency below which propagation occurs and above which attenuation takes place. All right. Okay. The operating frequency below which attenuation does not occur. None of these. Okay. So which option do you think might be the correct option? Think about it.
Madam, option B.
E is the correct one. Is that what you are saying?
Yes, ma'am.
All right. Can someone else tell me what will be the correct option? सोचो, think about it. सोचो, बताओ. Why are you saying option B will be the correct option?
Madam, here they're giving cutoff frequency. Then we are fixing some maximum cutoff frequency is it is like up to cutoff frequency we can able to transfer propagation will be occur. After cutoff frequency attenuation will be occur.
Okay.
I am thinking B only. Oh,
Okay.
okay.
Okay. All right. No issue. The option here is option A is the correct option. So here जो cutoff frequency है, the cutoff frequency means above that cutoff frequency the propagation will occur. All right. Above this cutoff frequency propagation will occur, and below this cutoff frequency attenuation will occur. All right. So option A is the correct option. Okay.
Okay, okay.
Okay. Okay. Good. Very good. Good for attempt. At least you are trying to attempt these questions. Very good. Okay. So question number 6. But no, let's not show the answer before discussing the question, right? Okay. So question number 6. For transporting,
Yes, ma'am.
yes. For transporting EM energy at microwave frequency, we prefer waveguides to transmission lines because, okay, so EM energy को अगर हमें transport करना है at microwave frequency, then why do we prefer waveguides instead of transmission lines? Why do we prefer waveguides instead of transmission line? Think about it. एक बार सोचो कि क्यों ऐसा होता है कि ईएम एनर्जी को हमको अगर ट्रांसपोर्ट करना है एट माइक्रोवेव फ्रीक्वेंसी, हम वेव गाइड प्रिफर करते हैं. सोच के बताओ.
Ma'am, you will explain, ma'am. Yes, ma'am.
ठीक है, आई विल एक्सप्लेन. ठीक है, हाँ, ओके. सो देखो, द ट्रांसमिशन लाइन्स कैन ओनली सपोर्ट TEM मोड. ओके, transmission line can only support TEM modes, and for other modes TE1, TE and TM modes, transmission line cannot be used. So we use waveguides. Okay, we use waveguides, so that's why waveguide is preferred. First statement is correct. Okay, now second statement, waveguides have larger bandwidths and lower signal attenuation. That is also correct. So waveguides here means a whole medium to transmit the EM energy. Okay, so waveguides have larger bandwidths and lower signal attenuation. This is also correct. In transmission line, there will be attenuation, there will be propagation, everything will be coming. For waveguides, it will have a lower attenuation and it will have larger bandwidths. Okay, so this option B is also correct. Now the option C, transmission lines are larger in size than waveguides. No, actually what happens is waveguides are larger in size. They are larger and bulkier compared to transmission lines. Okay, so if let's say transmission lines could support other modes as well and could have better bandwidth and better signal uh, lower signal attenuation, then we would have preferred transmission lines, because transmission lines are have smaller in size as well. Okay, so if transmission lines are smaller, so that means that we can have more it will be compact and everything, the system will be, so we would have preferred transmission line because waveguides are larger in size. So but it does not provide other modes and does not provide better bandwidth, so that's why we choose waveguides. Okay, समझ में आ रहा है? This is wrong.
Okay, okay.
चलो, option 7. Okay, sorry, question 7. The cutoff frequency of a waveguide does not depend on. Okay, so cutoff frequency of a waveguide does not depend on wave mode, dielectric property of the medium in the waveguide, dimensions of the waveguide. Yeah, I got a call, sorry. Yeah, so where was I? What was I telling you? So yeah, so
Madam, fourth one options are not visible, madam. Only question only visible. The cutoff frequency of a waveguide does not depend on.
yeah, ha, uh, does not depend on, yeah, sorry. So cutoff frequency of a waveguide depends on wave
Ah,
mode, right? It depends on the wave mode. Yes, it also depends on the dielectric property of the medium in the waveguide. This is also correct. And the cutoff frequency depends on the dimensions of the waveguide. This is also correct. So the cutoff frequency, uh, yeah, so the cutoff frequency here does not depend on, no, it depends on all of these properties. It depends on wave mode, it depends on the dielectric property of the medium, and it depends on the dimensions of the waveguide. So the correct option here will be none of these. None of these because कि कट ऑफ फ्रीक्वेंसी जो है वेव गाइड का वो इन तीनों फैक्टर्स पे डिपेंड करती है. सो अगर इफ इट वुड हैव सेड दैट the cutoff frequency of a waveguide does depends on, अगर ऐसा कुछ क्वेश्चन होता कि it depends on, then the correct option would have been all these three options. But here the option, the answer here is it does not depend on. So it does not depend on, so none of these. Okay, is that your was that your question, Arun? Was that your
Yes, ma'am. Okay, ma'am.
हाँ.
Before you are explaining on the time that options are not visible, madam.
अच्छा,
That's what.
is options are visible now?
Now visible, madam.
Is this both of my PPTs sorry PDFs are visible, right?
Yes, ma'am. Yes, ma'am.
Okay, okay, all right. हाँ, तो cutoff frequency of a waveguide depends on wave mode, dielectric property and dimension. So that's why here we will be choosing option D, that none of these. Okay, now let's go to question number 8. Question number 8 here is, sorry, a waveguide is used at, okay, waveguide is used at. So can someone from you tell me what will be the answer?
Option A, madam, microwave frequency.
Yeah, microwave is correct. Microwave ranges. Is there any other option that you think will be the correct, might be correct? Okay, option C here is also correct. The wave.
For lower frequency, we are going to use for coaxial cable, madam.
Yes.
But option 3, optical frequency means optical cable only, no?
No. So waveguide can also be used for this optical frequency ranges. All right.
Okay, madam.
Okay. So waveguide can be used for microwave as well as optical frequency ranges. Okay. Now let's go to question number 9. Question number 9 here is a 2 centimeter by 3 centimeter air-filled waveguide operates at 20 gigahertz with TM11. Here TM11 is given. So M is equals to 1, right? N is equals to 1. Okay. Using the formula information to solve questions 9 and 10, the cutoff frequency is. Okay. So cutoff frequency is ours, and 2 centimeter by 3 centimeter air-filled waveguide is also given to us. Okay, so how we are going to solve this question? Okay, so the formula for the cutoff frequency is this. This is the formula for cutoff to find out the cutoff frequency. That is F.
The formula is not visible. Now visible.
Okay. So Fc comma Mn 1 is equals to 1 upon 2 under root mu e whole under root m by a whole square m by a square plus n by b square. Here m and n are the modes, number of modes, that is 1 1. So we will put mn, we'll put, we know a and b, which is equals to 2 centimeter and 3 centimeter. Okay, we know c, right? C is speed of light, 3 into 10 to the power 8. We will put all these values and find out, right? It will be equals to 9.01 gigahertz. Okay, is there any problem here?
No, madam.
Okay, good. Let's go ahead. Question number 10. So question number 10 here says the propagation constant is. So for the same information given here, we have to find out the propagation constant. Again, for propagation constant, we know the formula, which is equals to mu omega under root mu e mu epsilon into whole under root 1 minus cutoff frequency upon the frequency squared. So we know we got FCM right through question number 9. F here is operating frequency here is 20 gigahertz. So we will put that, and we know all the other values. We will put it, and we will find out the value. Is there any issue here?
No, ma'am.
All right. So propagation constant का यहाँ पे formula is given to us, and we'll put all the values, and we will find out the answer. ठीक है? चलो. So do you have any doubt for today?
Madam? Madam, for offline exam, they will ask a question around these 12 assignments only, no, madam?
Yes.
Okay, madam. That one only I have.
Is there any other doubt? Okay, so all the best for assignment 10, and I hope you perform well. Right, Gokul, do you have anything to say to us? Say to me?
No, ma'am. No, ma'am.
All right. Okay. So
Thank you, ma'am.
chalo, all the best. Bye bye.